Hello, students. Today we're going to be covering conditional statements. Now, if after last week you were like, man, I could really use a break from numbers. I'm kind of tired of looking at all these numbers, algebra, all this. Well, your prayer has been answered because conditional statements are more of a logic thing. They don't deal with numbers, more with statements and reasoning and logic. I'm a big fan of this unit just because there's a lot of room for creativity, which is sparse in mathematics sometimes. So I'm really looking forward to doing this lesson with you all. And I'm just getting a little organized. My pens were all over the place. Okay, so starting out, let's talk about what on earth a conditional statement is. So I'm going to zoom on ahead to page 15. I forgot I have to date this. All right, so a conditional statement is a statement written in if-then form. Oops, let's get that on the screen right. There we go. So again, a conditional statement is a statement written in if-then form. Any statement in the world can be put in this, not just mathematical statements. If I got a good night of sleep, then I will be energized for the day. That's an example of an if-then statement. And of course, the logic on that one is subjective. Some people can sleep 8 hours and still be tired when they wake up, but just giving you the general idea of what an if-then statement is. So there's two little important terms with this. The hypothesis is the statement after if, and the conclusion is the statement after then. So going back to my verbal example, if I get a good night of sleep, then I will be energized for the next day. My hypothesis is I get a good night of sleep. It doesn't include the if, it is after the if. So my hypothesis is I get a good night of sleep. That's a statement. And then the conclusion is the statement after the then. So if I get a good night of sleep, then I will be energized for the next day. The statement is, I will be energized for the next day. So it's the statement after the then, not including the then. You can think about it like in science, the hypothesis is what you start with in the scientific method. And in English, a conclusion is what you end with. So this is the start and this is the end. So let's get ourselves a nice little example, If the sum of the measures of two angles is 90 degrees, then they are complementary angles. So we have an if and a then, if something, comma, then something. And those two somethings are our hypothesis. So that statement of the hypothesis would be the sum of the measures of two angles is 90 degrees. And then our conclusion follows. They are complementary angles. There's our hypothesis. And that's our conclusion. And we can see our if-then clearly. Now, one of the reasons we use conditional statements in geometry is, for the most part, our theorems are all formally written as a conditional statement. So, for example, looking back at the day before, well, the last lesson, I should say, these were all technically theorems. And the theorem in conditional statement form would be if two lines, or if two parallel lines are cut by a transversal, then the corresponding angles are congruent. If two parallel lines are cut by a transversal, then the same side interior angles are supplementary. It's a logical process that says if this condition is met, then you can know that this condition is true. If the condition that the two lines are parallel and cut by a transversal is true, then you can know that this is true. So it's often used to emphasize a given, because it isn't the fact that every pair of corresponding angles is congruent in the world. It's only congruent if the two lines are parallel that are cut by a transversal. So we like to do our theorems in if-then form because they include the criteria needed for the conclusion to be true, and also for one other interesting reason. So you can rewrite and move around conditional statements in many forms, many variations. Oh, but real quick, I forgot a little bit from my notes. So we're going to practice rewriting a statement as a conditional statement. So that's kind of what I just did over there. So you can rewrite many statements as conditionals. So many of the things we know in geometry, for example, an obtuse angle has a measure greater than 90 degrees. Now that's something that we know, but it isn't written in if-then form. So if you're ever given a statement and you need to rewrite it in if-then form, here's the general idea. So to start, I'm going to take a look at what they're talking about first. What is the first subject? An obtuse angle. And then what does the rest of it have to do with the obtuse angle? Well, it has a measure greater than 90. So if an angle is obtuse, then it has a measure greater than 90. So if an angle is obtuse, then it has a measure greater than 90 degrees. And lastly, there's a lot of variations of conditionals. These are ways that we kind of move around or change the conditional statement to try and figure out if it's still a true message. So for example, here we have if an angle is obtuse, then it has a measure greater than 90. What if we flipped it? If an angle has a measure greater than 90, then it is obtuse. Is that still true? Well, I think so. I mean, unless you want to get into technicals of if it's 180 degrees, then it's a straight angle. And if it's above 180, then it's a, oh goodness, it's been a while. I think it's called a reflex angle. So then it has some exceptions, and maybe it isn't necessarily true. But I think for the most part, it has truth to it. There are some conditional statements and theorems in geometry that are only true in certain variations and not true in others. And that can help us immensely later on in the course. I promise everything we learn in here is for some sort of reason. So we're going to pick an original statement and we're going to learn about the different types. So our original statement that we're going to make variations of is if it is Saturday, then there is no school. I don't know about you guys, but I wish it was still Saturday. So we're going to take this statement as face value. We're going to assume that this is based on a traditional 5-day school week where you go to school Monday through Friday and not on Saturday and Sunday. So we're not going to count Sunday school, Saturday school, any of that stuff. All right, so the first type is called the inverse. I like to call the inverse the not-not. It's the not-not. The reason I call it the not-not is because you are negating both the hypothesis and the conclusion. So that's just my shorthand, negating both the hypothesis and the conclusion. Negate means to, essentially, if you say it is, to negate it says it isn't. And if you say it isn't, to negate it would be to say it is. So kind of like the little nuh-uh, nuh-uh, nuh-uh that little kids do to everything you say, that would be like they're negating my statements. So the inverse of that statement would be if it is not, I got to put that not in there. If it is not Saturday, then there is not no school. Well, I wouldn't really say not no school. So if we're saying originally there isn't school, then we're going to say there is school. And at first glance, this seems a bit reasonable, no? I mean, if it's not Saturday, then I guess I'm at school. But what about Sunday? So whenever we do these, inverse and the other ones, we're trying to figure out, are these statements still true when I do them, or have I changed the statement in such a way that it's no longer true? The way to tell if the statement is still true is, well, can you think of an example that makes it not true? So is there a hypothesis that you could fit in there that would make that true? So a day that is not Saturday, but still does not have school. What about Sunday? I sure hope I'm not at school on a Sunday. It's not Saturday, but there isn't school. So we could say Sunday is a counter example, which means that the statement above is false, because just because it isn't Saturday doesn't mean there's school. It could also be Sunday. I want my 2 days of the weekend. You can't take those away from me. All right, so the next one is called the converse, like the shoe. And if the inverse is the not, the converse is the flip-flop, like a shoe. I have a theme going here. Another way to think about the converse is if you were to take your right shoe and put it on your left foot, and your left shoe and put it on your right foot. This is where you switch the hypothesis and conclusion. Here's where it's important to remember that the hypothesis does not include the if. It doesn't include the if. And the conclusion does not include the then. So when I flip this, it's not going to be then there is no school if it is Saturday. I'm switching the hypothesis and the conclusion. It's still going to be an if-then statement. So if is still how I start, but I'm going to write there is no school. Then, looking at the hypothesis, it is Saturday. And now we can ask, is this true? Well, if I'm not at school, then it has to be Saturday. Well, we just said Sunday also counts. So Sunday is also a counterexample to this statement. And because we found a counterexample, the statement isn't true. But we'll talk more about counterexamples tomorrow. For today, I want to focus on conditional statements, inverse, converse, and the last one, contrapositive. This is a long, weird word, contrapositive. And it is the longest one, and so I think of it as both of these put together, the not flip-flop. Because it does both negate and switch. So I usually like to find the contrapositive by either looking at my inverse or my converse, but honestly the converse is the easiest. I flip-flop it first. So I take it from if it is Saturday, then there is no school, to if there is no school, then it is Saturday. I flip-flop it. And now I put the not. So if there is not no school, or if there is school, then it is not Saturday. I put those nots in there. So if there is school, then it is not Saturday. Now, can we think of a counterexample for this? Well, Sunday is a day there isn't school on Sunday, so that isn't a counterexample anymore. Monday through Friday are days where there is school, and it's not Saturday. So I can't think of any counterexamples for this. I mean, if I'm at school, it's got to be Monday, Tuesday, Wednesday, Thursday, or Friday. Saturday and Sunday, I'm at home. So I'm just going to make a note. We found no counterexamples, so that statement is true. Now, an important note is notice how it went from there is no school to there is school. Negate, or the not, doesn't just mean that it's a negative statement or there has to be a no or a not. If there already is a negative statement or a no or a not, then you're getting rid of it when you negate it. You're going to make it a positive. So you're just switching the sign of it. Think of like a negative number. If the number is already negative and you multiply it by a negative, it doesn't stay negative, it becomes positive. So that's the idea of what we're doing when we negate it. We're switching the sign to the other sign. If it's negative, we make it positive. If it's positive, we make it negative. All right. So there are so many examples of conditional statements out there, and I'll post some in the Schoology, but this video is already pretty long, so I'm going to cut it off. I hope you all are having a wonderful day so far, and if not, then I hope tomorrow's better. There's always tomorrow. All right, I'll see you next time.